Hello everyone, in this video we're going to review Unit 10, Topics 10.1 to 10.10, Sequences and Infinite Series. Alright, first I'm going to show you the strategies for testing series. Now we have total 10 tests, right? But each of which will be tested on the AP Calculus BC exam. Now suppose you given the infinite series a sub n, right? So what you need to do is to find the limit of a sub n when n approaches infinity, right? You have two possible cases. Now you're going to check to see if this limit equals 0 or not, right? If the limit of this series not equal to 0, right? So you have this case right here. Then the series divergent by the n-term test or divergent test right here, right? Now, if the limit of a sub n when n approaches infinity equals 0, so it's going to be yes. You're going to check to see if the series is geometric. Now, if the series is geometric, then you're going to check the absolute value of common ratio to see if it's less than 1, right? If it's yes, and then the series converges, right? If it's no, and then the series diverges, right? If this series is not geometric, then you're going to check to see if there are positive terms. If no, and then you're going to check to see if the sign alternates. If yes, and then you're going to check to see if the series decreasing. If the series is decreasing, then the series converges. If the series not decreasing, and then you're going to try absolute convergence. Now after you check the sign and you don't see the sign alternating, and then you're going to try absolute convergence. If there are positive terms, we're going to think about the p-series first, right? Now you're going to check to see if this series is a p-series. If it is, and then check to see if p greater than 1. If yes, and then the series converges, right? If no, and then the series diverges, right? Now, what if the series right here is not a p-series? Think about the integral test. Now, if this one is, the series converges. If you cannot use the integral test, think about the ratio test. If you succeed, and then the series converges. If you cannot use the ratio test, think about the root test. If you succeed, and then the series converges. If not, think about the direct comparison test. If you succeed, and then the series converges. If not, think about the limit comparison test. If you succeed, and then the series converges. Now here's the series test for convergence or divergence that we will use in the tree diagram. Alright, first we have the definition of the infinite series. Now the first test is called the n-term test or divergent test. The second one is going to be geometric series. The next one is going to be p-series and harmonic series. The next one is going to be integral test. Next is going to be ratio test, the root test, direct and limit comparison test, the alternating series test, And the last one, absolute and conditional convergence. Now, for problem 1 to 5, be sure to justify your conclusion by thoroughly demonstrating the test you use, right? Now, question 1 and 2, we talk about the sequence and series, right? To remember the difference between sequence and series. Sequence is a list of numbers, and series is a sum of numbers. For example, I have the sequence a sub n equals 1 over n, right? If n equals 1, I'm gonna get 1. N equals 2, I get 1 half. N equals 3, I get 1 over 3, right? I just list the number, right? Now, for the series right here, I need to put the summation in front of this one. So it's gonna be a sub n like this, right? N goes from 1 to infinity. N equals 1, we get 1. N equals 2, we get 1 half. N equals 3, we get 1/3, right? So we need to add them up. Now we're going to go back over here. Does the sequence a sub n converge or diverge, right? So we're going to find the limit of 3n over 2n minus 1 when n approaches infinity, right? Now we're going to use the relative growth rate, right? So we can ignore this guy, right? Because when n approaches infinity, this guy right here grows faster than 1, right? So this guy turns out to be 3 over 2, because you cancel out n and n, it's going to be 3.5, right? So we can say that this sequence converges, right? Now, number 2. Does the series a sub n converge or diverge, right? Now we'll find the limit of 3n over 2n minus 1 when n approaches infinity, right? Again, it's gonna be 3.5, right? And this guy actually different from 0, right? So, by the n-term test right here, the series diverges, right? Question 3. Use the n-term test on the series and state its conclusion. Alright, so we're going to use limit 6n over 4n squared plus 1 when n approaches infinity, right? Again, we're going to use the relative growth rate, right? So we can ignore this guy, right? So it can be limit of 6 over 4n, right? Because you can cancel out n. Now when n approaches infinity, the bottom approaches infinity, the top approaches 6. So it could be 0, right? So using the n-term test, it could be inconclusive, right? If the limit of a sub n equals 0, the n-term test is inconclusive. Now number 4, can you find the sum of the series? If so, find that sum. Alright, so this one can be written as n goes from 1 to infinity of 2 over 5 altogether raised to the n, right? And you have 1 over 5 right here, right? And this guy actually the geometric series, right? With the common ratio equals 2 over 5, right? Less than 1, right? So by geometric series test, the series converges to a over 1 minus r, right? Look at the geometric series right here, right? Now a is the first term which means n equals 1. Substitute 1 for n over here. We have 2 over 25, right? Over 1 minus 2 over 5. So if we simplify this one, it turns out to be 2 over 15, right? Now let's move on to question 5. This guy actually telescoping series, alright? So first we need to expand this one. If n equals 1, we get 1 minus 1 over 3, right? N equals 2, we get 1 and half minus 1 over 4, right? n equals 3, we get 1 over 3 minus 1 over 5. N equals 4, we get 1 over 4 minus 1 over 6, right? Now, we're going to generalize this one. So what if n equals k minus 3, right? So we have 1 over k minus 3 minus 1 over k minus 1. Now n equals k minus 2. We get 1 over k minus 2 minus 1 over k, right? Now n equals k minus 1. We get 1 over k minus 1 minus 1 over k plus 1, right? And the last one, n equals k. Then we get 1 over k minus 1 over k plus 2. Remember, the telescoping series has the term cancel, right? So look, this guy and this guy cancel out. This guy and this guy cancel out. Now this guy and the terms somewhere right here cancel out, right? This guy and the term somewhere right here cancel out, right? This guy and this guy cancel out. This guy and this guy cancel out, right? This guy and the term somewhere right here cancel out, right? So we only have the 4 terms left, the first, the second, and the last 2 right here, right? So it's gonna be, now I'm gonna take limit of this one, so I'm gonna factor -1 out, right? So it can be like this, right? When k approaches infinity, right? So this guy approaches 0, this guy approaches 0. We only have this one left, it could be 3.5, right? Now let's move on to question 6. Match the series with its behavior by circling the appropriate word. Alright, question A. The series 1 over n to the e. This guy actually the p series, right? So the series converges, right? Because p equals e greater than 1, right? Now question B. This guy actually the p series, right? And p equals ln 2, which is less than 1. The series diverges, right? Now let's move on to question 7. Find the common ratio if it exists in the series, right? So this is actually the geometric series, right? In order to find the common ratio, you just take the next term divided by the previous terms, right? So the next term right here, -9 over 2, divided by 3, right? So it could be -9 over 6, which is -3 over 2. Now, we have another way. R equals this guy right here, 27 over 4, divided by -9 over 2, right? And multiply the top bottom by 4, right? So it's going to be 27 over -18, right? Now divide the top bottom by 9, so it can be -3 over 2, right? The common ratio is -3 over 2. Now question 8. How many terms of the series are needed to approximate the sum of the series with an error that is less than 0.001? Alright, so this is the alternating series, right? So we're going to use the alternating series error bar, right? So we have error equals absolute value of the sum of the infinite series, subtract the partial sum, right? And this guy is the error bar, right? And this guy must be less than or equal to the next omitted terms, right? It could be a sub n plus 1. Now a sub n is right here, right? So a sub n plus 1 actually 1 over n plus 1 altogether raised to the 4, right? And we need this one to be less than 0.0001, right? So this one less than 1 over 1000, right? Now I'm gonna take reciprocal both sides, so it turns out to be n plus 1 power 4 greater than 1000, right? We're gonna take 4 root both sides, right? So it could be n plus 1 equals 4 root of 1000, right? We're gonna hit the button right here, this guy right here, 4 root of 1000. Press Ctrl Enter. It's gonna be 5.623, right? So n equals 5.623 subtract 1 is gonna be 4.623, right? Now n greater than 4.623 and n must be an integer, right? So the least number should be 5 right here. Question 9. If the series a sub n equals 1 over n raised to the 1.01 converges, which of the following series also converges by the direct comparison test? Question A. This guy actually the harmonic series where p equals 1, right? So this one diverges by the p series, right? Now this one can be written as 1 over n power 1 half, right? So 1 half less than 1. This one diverges, right? Now this one right here, it will take absolute value of this one. And it turns out to be the series of 1 over n power 1.01, right? And this guy actually right here, right? But this one converges, so this one is the right answer, right? Now we're going to check question D right here. P equals 0.09 less than 1, right? So by the P series, this one diverges, right? And this one, P equals 0.01 less than 1, right? By the P series test, this one diverges. Now, question 10. Find the sum of the series 1 minus 1 over 3 plus 1 over 3 minus 1 over 5, etc. Right? So if we keep doing this one, it turns out to be 1 over 7 minus 1 over 9, right? Plus etc. Now, we need the two general terms right here. So how do we find the general terms, right? So we look at this one right here. 3, 5, 7, right? So we have 3, 5, 7 right here, and we have 1 right here, right? So right here n equals 0, n equals 1, n equals 2, n equals 3, right? In order to get 3 from 1, we're going to add 2, add 2, add 2, right? And this guy actually arithmetic sequence, right? So we have a sub n equals a sub k plus n minus k times d. This is the formula to find the general term, right? So we have a sub n equals a sub k. For example, I'm going to pick this guy. 1 plus n minus 0 times 2, right? So I'm going to simplify a sub n equals 2n plus 1, right? So I have 1 over 2n plus 1 right here. And the terms before that should be 1 over 2n minus 1, right? Subtract. So this guy cancel out, this guy cancel out, this guy cancel out, right? This guy and the terms right here cancel out, this term and the term before it cancel out, right? So we only have this guy and this guy left, right? So it's gonna be 1 minus limit of 1 over 2n plus 1 when n approaches infinity, right? The bottom approaches infinity, right? So it could be 1 minus 0, it could be 1. So the answer is D, right? Now let's move on to question 11. Which of the following series is absolutely convergent, right? So we're going to take absolute value of each of this one, right? So we have absolute value of this one. It turns out to be the series 1 over n raised to the 0.99 when n goes from 1 to infinity, right? This guy actually the p series where p equals 0.99 less than 1, right? So the series diverges, right? Now question B. take absolute value of this one is going to be the series 1 over n squared, right? Now this guy again is a p series, right? Where p equals 2 greater than 1. So this one converges by the p series, right? Now question C, we're going to take absolute value of this one. So it turns out to be the series 1 over n. This guy diverges because it's going to be harmonic series, right? Question D, take absolute value of this one. It's going to be the series of 3 raised to the n, right? And this one actually the geometric series, right? With the common ratio equals 3 greater than 1. So the series diverges by the geometric series, right? And the last one, the absolute value of this one is going to be the series 1 over ln of n, right? Now we know that n always greater than ln of n, right? Now I'm going to take reciprocal, so it could be 1 over n always less than 1 over ln of n, right? Now this one right here diverges by harmonic series test, right? So by direct comparison test, this series right here diverges, right? So the answer must be B. Now question 12. Which of the following series is conditionally convergent? Alright. We're going to take absolute value of this one. So it's going to be the series 1 over n squared. This one is absolutely convergent by p series test, right? Now question B. Take absolute value of this one. It's going to be 1 over square root of n is going to be n power 1 half, right? And this guy is divergent by the p series test, right? Because p equals 1 half less than 1. Now question C. Absolute value of this one is going to be the series 1 over n cubed, right? And this guy absolutely convergent by p series because p equals 3 greater than 1, right? Check absolute value of this one is going to be the series 1 over n factorial, right? This guy is absolutely convergent by the ratio test because you have limit of a sub n plus 1, which means 1 over n plus 1 factorial over a sub n, which is 1 over n factorial. When n approaches infinity equals limit of absolute value of 1 over n plus 1 factorial times n factorial over 1 when n approaches infinity, right? N plus 1 factorial is to be n plus 1 times n factorial, right? This guy cancel out. So it could be limit of absolute value of 1 over n plus 1 when n approaches infinity and this guy equals 0, right? Less than 1, right? So it could be absolutely convergent by the ratio test right here, right? Now the last one, if you take absolute value of this one, it's going to be the series e to the n, right? And when n approaches infinity, this guy divergent by the n term test, right? The question wants you to find the series that is conditionally convergent, right? So the first one is absolutely convergent. We're going to cross this one out, right? The second one could be, right? The third one, absolutely convergent. We cross this one out. Question D, absolutely convergent by the ratio test. We're going to cross this one out, right? Now question E could be, right? Now for question B right here, we're going to use the alternating series test. The series right here converges if limit of this one right here equal to 0 and this one right here is a decreasing sequence, right? So we're going to check to see if it's right or wrong, right? So we have limit of b sub n is going to be this guy right here. 1 over square root of n when n approaches infinity, right? So it could be 0. That's correct, right? And you know that b sub n equals 1 over square root of n is a decreasing sequence, right? Because when n getting bigger and bigger, this sequence getting smaller and smaller, right? So two conditions are met, then this series converges. The answer must be B. Now question 13, very simple. This one is the geometric series where the common ratio equals 2 over 5, which is less than 1, right? So the series converges to a over 1 minus r, right? Substitute a equals 1, right? Put 1 right here. A over 1 minus 2 over 5, right? So we're going to multiply the top bottom by 5. So it could be 5 over 5 minus 2. It could be 5 over 3, right? The answer must be D. Now question 14. If this series diverges, which of the following series also diverges? The answer obviously C. Why? Because we can rewrite this one as 0.5 times the series 1 over n, right? So the constant right here does not affect the convergence, right? So if the original one right here diverges, the new one right here must be divergent, right? Now let's move on to question 15. Consider the series -1 raised to the n plus 1 over n to the p. Determine the values of p for which the series converges. Alright, so we look at this one right here. Alright, it's gonna give you a hint. We need to use the alternating series test, right? So I'm gonna let a sub n equals 1 over n to the p, right? Now, in order to use the alternating series test, you need to check to see if a sub n greater than 0. Yes, it's greater than 0, right? Now, next, you're going to check to see if a sub n equals 1 over n to the p is decreasing. This guy is decreasing if p greater than 0, right? If p positive. Now, third one, you need to check to see if limit of a sub n, which means 1 over n to the p when n approaches infinity, this guy equals 0 if and only if b greater than 0, right? So, to summarize this one, the series converges if p greater than 0, right? By the alternating series test, right? Now question B. Find the maximum value of the error if k terms are used to approximate the sum of the series, right? So we're going to use the alternating series error bound, right? So it's going to be the error equals absolute value of s sub infinity subtract the partial sum. This guy actually the remainder, and it should be less than the first omitted term, right? Which is absolute value of a sub n plus 1, right? Now, the first omitted terms is k plus 1 terms, right? So it's going to be 1 over, instead of n, I'm going to put k plus 1, right? Raised to the p. And this one is the maximum error. Now, question 16 to 18, we are allowed to use the calculator. Now, question 16, we need to find the sum of this sequence, right? So we're going to bring up the calculator. Press the button right here, and then you're going to hit this guy. and then press Ctrl Enter. The answer is 0.783, right? Now question B. What is the maximum value of the error of this series if the sum of this one is approximated by the answer in part A? If we use the part A to do part B, we see that n equals 10, right? And then the first omitted term should be n equals 11, right? So we're going to use the alternating series error bound, right? So it's going to be absolute value of s sub infinitive subtract s sub 10. This guy must be less than or equal to absolute value of the first omitted term, which is a sub 11, right? But a sub 11, substitute 11 for n over here. So we have absolute value of negative 1 raised to the 12 over 11 raised to the 11, right? And it's going to be 1 over 11 raised to the 11, right? If we want to convert this one to decimal, we just use the calculator, right? Press Ctrl Enter. It's going to be 4 times 10 to the negative 12, right? Now question C. If the sum of the first 20 terms was used instead in part A, would the error in part B be increase or decrease? Alright, so we do exactly the same thing, right? Error equals absolute value of s sub infinitive subtract the partial sum. This guy less than absolute value of a sub 21, right? So it's going to be absolute value of negative 1 raised to the 21 plus 1 over 21 raised to the 21, right? So it's going to be 1 over 21 raised to the 21, right? And this guy absolutely less than 1 over 11 raised to the 11, right? So we can conclude that the error would be decreased, right? Now let's move on to question 17. Find the sum of the series negative 1 to the n over n squared. Correct to 3 decimal places. State the number of terms needed to arrive at the answer. Alright, so when we see this guy right here, actually negative 1 raised to the n, think about the alternating series test, right? So we're going to use the alternating series error bound, right? So we have error equals absolute value of s sub infinitive subtract the partial sum. This guy must be less than the first omitted term, which means a sub n plus 1, right? And this guy must be less than 0.001, right? 3 decimal places. So we have a sub n right here equals 1 over n squared, right? Then a sub n plus 1 equals 1 over n plus 1 altogether squared, right? So we have 1 over n plus 1 altogether squared less than 0.001. This guy actually 1 over 1000, right? So we have 1 over 1000 here. Now we're going to take reciprocal both sides, so it will be n plus 1 altogether squared greater than 1000, right? Then check square root both sides, so it will be n plus 1 greater than square root of 1000, right? Then n greater than square root of 1000 subtract 1, right? So we're going to bring up the calculator, press the button right here, check the square root right here. 1000 subtract 1, press Ctrl Enter. It's going to be 30.622, right? But n is an integer, right? So the least number should be n equals 31. So the series becomes negative 1 raised to the n over n squared when n's go from 1 to 31. 1, right? So you're going to print up the calculator, press the button right here, pick the summation notation right here, right? And it's go from 1 to 31. Hit the fraction, -1 raised to the n over n squared, and then press Ctrl Enter. It's going to give you -0.822, right? Now question B, we're going to do exactly the same thing, right? So we have error equals absolute value of s of infinity subtract s of n less than the absolute value of the first omitted term, right? Which is a sub n plus 1. And this guy actually less than 0.001, right? So the first omitted term should be 1 over n plus 1 factorial, right? This guy right here is a sub n, right? And this guy less than 1 over 1000. So check reciprocal, both sides could be n plus 1 factorial greater than 1000, right? Now we're going to test n equals 1. We have 2 factorial. It's less than 1000, right? N equals 2. We have 3 factorial, which is 6, right? N equals 3. We have 4 factorial, which is 24, right? It doesn't work, right? N equals 4. We have 4 plus 1 could be 5. It could be 120. It doesn't work. N equals 5. We have 6. It could be 720. N equals 6. It could be 50, 40. So this one greater than 1000. Right? So this one works, right? So N equals 6. Now we have the sum from 1 to 6. -1 raised to the n over n factorial, right? So we're going to print up the calculator. I'm going to copy this one down over here. Press the button right here. And then press Ctrl Enter. It's going to be -0.631. Now, question 18. Find the error when the alternating series is approximated by the first 4 terms of the series, right? So again, we're going to use the alternating series error bound, right? So we have error equals absolute value of s of infinity subtract the partial sum, right? And this guy actually less than absolute value of a sub 4, right? The first 4 terms. And it's going to be -0.25 raised to the 4, right? So it's going to be, we're going to print up the calculator. -0.25 raised to the 4. Press Ctrl Enter. It's going to be 0.0039, right? Now question B. Find the exact sum of the series and use it to find the actual error between the exact sum and the approximate sum using the first 4 terms of the series. Compare the answer to the question A, right? So we have the sum equals the series -0.25 raised to the n, and it's go from 0 to infinity, right? Now this guy actually geometric series where the common ratio equals -0.25, right? So absolute value of common ratio right here less than 1. So then geometric series converges, right? And it's going to be a over 1 minus r, right? A equals 1 right here. 1 over 1 minus -0.25, right? And then it's going to be 1 over 1 plus 1 over 4, right? Multiply the top bottom by 4. So we have 4 over 4 plus 1 it's gonna be 4 over 5, right? Error is absolute value of the series subtracted partial sum, right? Which is the sum of the series subtract s sub 3, right? The first 4 terms we need to use s3, right? So it's gonna be 4 over 5 subtract s3, which means the sum negative 0.25 raised to the n when n's go from 0 to 3, right? So it's going to be absolute value of 4 over 5 minus, we're going to print up the calculator. It's going to be 0.7968, right? 0.003125, right? Now we're going to compare this number right here with this guy right here. And we see that 0.003125 less than 0.0039, right? And it's your time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand